Let's have a look at some calculus rules that are going to make life a little bit easier. And the first one we look at is what we call the chain rule. Now, the formal definition is something like this. So u is some function of x. So if you want to differentiate some function of x which has been raised to a power, and then you get n minus 1 times u dash, something like that. And to be honest, I've never used that in my life, but that's the formula. Much easier way of thinking about it is this: anarchy, right? Because anarchy is when you bring down the power. Okay? So anarchy, bring down the power, but then you want to teach them a lesson, so you then throw them on the ground. So not only do you bring down the power, then you lower the power, so you throw them on the ground. And then you really want to hurt them, so you put the boot in and you try to kick their insides. You get their insides out. Then that's where we diff the inside. So you think of it as anarchy. Bring down the power, lower the power, put the boot in, and you diff the inside. Okay? But one of the reasons I think of it like that is because really I do it as I say it. So here's one where we looked at before, but we had to expand it out. Reality is I probably would expand this one out anyway, because it's quite simple, but let's pretend we're not going to expand it out. So differentiate, bring down the power, the 2 comes to the front. Lower the power, so now I change the 2 to a 1. Diff the inside, we need to bring the derivative out. So whatever's inside those parentheses, that's what I differentiate. So I differentiate 2x plus 1. Obviously that's 2, and we end up with 4 outside of 2x plus 1. Which is the same answer that we got before. This is before we wrote it as, I think it was 8x plus 4, it wasn't factorised. But we still get the same answer. Now, the advantage of something like that is I can now have much higher powers. Because to expand out 3x minus 4 to the power of 7, going to take us a bit of time. There's going to be several terms. But now all I've got to do, bring down the power, 7, lower the power, 6, diff the inside, and that's 3. And then I can tidy this one up. 7 3s obviously are 21. And we get a nice, neat answer. Now, once we look at how to differentiate more functions, that's when it's going to start becoming really useful. So trig functions and log functions and things like that. So x squared minus 10 to the power of 3, bring down the power, 3, lower the power, 2, diff the inside, in this case that's 2x, tidy it up, 6x, x squared minus 10 squared. Now this one has a number out the front already, but that's alright. When I bring down the power I just multiply. So bring down the power, 6 5s become 30, lower the power, 5, diff the inside, negative 2, so I get negative 60. So I just find that so much easier than mucking about with this and going, oh, what's u dash and all that. I just think of it as, bring down the power, lower the power, diff the inside, bang, you got it. Here's another way of writing the chain rule, and it's to do with rates of change, which we'll look at a bit later too. It's all the same idea. You see, chain rule, rates of change. Another word for it is implicit differentiation. It's all the same idea. So dy dx, if I had my equation in parametric form, remember we looked at parametrics. So I said, well, I know the x is 4t, the y is 2t squared. Now, yes, I could eliminate the t and come up with whatever the function is. But using this idea, I don't have to. Because I can say, in order to find dy dx, what I'll do is I'll differentiate y with respect to t. I'll also differentiate x with respect to t, and then I can play around with those. So dx to t would be 4, dy to t would be 4t, so dy dx will be dy to t, 4t, the t dx, well that's just the reciprocal of dx to t, a quarter, so I can just leave it in terms of its parameter. So dy dx is just t. I mean, if you wanted to get it in terms of x, good, eliminate the parameter. X is 4t, so if I make t the subject, what am I going to get? X on 4. So the derivative is x on 4, if I want it in terms of x. There's the idea, chain rule, rates of change, implicit differentiation, as I say, it's all the same thing. So we'll have a go at those. And